Hello and welcome to a new series here on structural coverage. Let's code ESP8266. What we can see here is the Qlock table, also a word clock, but in real life. So the case is printed with a 3D printer and the electronics are powered by an ESP8266. Everything is open source, so the Gerber files, the 3D printer files, the code. So I will put a link into the description to GitHub. And sometimes I have some fragments in the first row on the left side, so some of the colors are not displayed correctly. So what we will do first is we will take the multimeter and we will check if plus is connected and minus is connected. So whenever we hear the dude, that means there is a connection between. So let's check here, they are connected. And here we also have a connection. Let's check the row. That looks good. Sometimes it's not so easy to hit the pins. But that seems alright. So, fortunately we cannot measure the data lane, the power lane. We'll get rid of the grid here and let's have a closer look if we can see any bad soldering there. Better with some light. And let's see. Must be somewhere at the top right, because yeah, the left LEDs make the problem. So somewhere on the first row on the right side there must be some bad connection. Maybe here, yeah, maybe here between the fourth and the fifth LED from the right. That could be actually the problem. Let's turn on the clock and let's see again where we can see the fragments. There we have it. Let's turn it again on. And yeah, now we can clearly see between the fourth and the fifth LED. There we have the issue. I'm gonna plug it out, plug it in again. See some different flashing from there on. And there it is. Okay, there seems to be the issue. Let's try to fix that. Let's just take a little bit of new sin. It's not so easy to solder in this position. Quite far away. But it's better for the camera. So we will manage. That looks good. That looks good. Let's keep it like this and let's try it again. Let's check if we have still the artifacts. That looks much better. Okay, let's quickly jump into VS Code, run some test program if everything works well. So here we are now on my computer in Visual Studio Code. This time we will use Visual Studio Code because I've not installed NeoVim on this machine here, and it's hard to connect my development environment directly to the Arduino. That's why we're doing this on this machine here. And here we can see the actual Qlock table code that is also available on GitHub. But in order to test now if the colors are working properly, we will use demo code, this one here. What this will do is we will just define here the right pin. So in our case it's pin 5 that is connected to the LED stripe. We have 114 LEDs. We will reduce the delay a bit. And what will happen here, we just call this pixel begins. Then in our main loop, we just clear all the pixels. We loop over every pixel. We set the color to light green. We'll change this to really more like red, to real red. Then we just show the pixel. We will wait for 100 milliseconds. We will turn on the next pixel and so on until all pixels are on. And then it will just start from the beginning. Also here, just copy paste this here quickly to change this mode here, and then we are good to go. Probably I forgot to select the right port. No, it's using COM3. That should be the right one. Yes. So we'll now upload the test code, and then we will see if all the LEDs are red. Now it's just uploading the code. And once that is done, that looks really good. Let's all the crucial LEDs. That looks perfect. Let's try it one more time with a different color. With a blue. Let's upload that one. That looks promising. But yeah, the last row was really the one with the issue. So it seems like really the soldering helped. Perfect. Okay, that seems to work. We don't need this one anymore. We don't have to save. And then we can just here select the right serial port, and we can trigger the upload of the actual watch code. And here we are. That looks perfect. Let's switch the table here again. Let's plug out this USB cable and let's try it again with a real power supply. And we will also add the cover plate again so that we can actually see the time. Zack. Of course, this is German because I'm coming from Germany. Es ist 8:05. It is 5 to half 9. Perfect. The minutes are working. So we fixed the bug. Only soldering was needed, nothing in the code. So hopefully we will also have the chance in some other videos about the Qlock table to also have a look into the code, how it works, especially the transition between the time is quite interesting. But of course, this is open source. You can also have a look into my GitHub repository. I will add a link to the description. And then thank you for watching and bye bye.